Hey guys, today we're going to learn how to code. I'm Victor Garcia. I have around 3 to 4 years of experience and I mainly code in C++, but today we're going to use Java. And we're going to use Java to turn this image of a donut into an image of a donut, but only being able to use Ascii characters. How do we do that? Well, first off, our program has to grab a file from our computer. So it has to grab a file, it has to read it, and save it in memory. We want to be able to resize this to the dimensions we want because this image could be a lot larger or a lot smaller than what we want it to be. Okay, now that we resize this image, we want to be able to search through every single pixel in the image. And every time we search through every single pixel in the image, we want to grab that pixel. So let's do a zoomed in version of this pixel. This pixel has a red channel, a blue channel, and a green channel. It might also have an alpha channel, but that's not important for now. So now that we have 3 values, we want to be able to turn that into one value between 1 and 0. Why is that? Because this image has no color information. So what we're going to do is we're going to grab these colors and we're going to map them. We're going to map them into a value between white and black. Now that we've done that, and we've done that for every single pixel, which character we want to represent that pixel. So why did we choose these values? Well, as you can see, the @ symbol takes up a lot more space than the period symbol. And this represents a white or a very bright part of the image. This represents a very dark part of the image. We're going to have to map this pixel's value to one of the elements in this array. Once we're done that, we just output it to the terminal and we should get a lovely image. So let's get coding. I have my tutorial class ready to start making something. And down here is a terminal where we're going to run our program as well as we're going to see the output of our program. So hopefully by the end of this, you should see a donut or whatever image you want it to output down here. Here we have all the imports. We're using image IO, that way we can work with images in our code. We're using buffered image, that way we can store the image in memory. We're using io.file, that way we can read from a file on our computer. And we're using IO exception for any errors that happen while we're reading the file. And now we're going to make our main function. So public. What we first want to do is we want to read the file and save it as an image. So we do that by using this buffered image class. We're going to create an image io.read new file, and then this is the actual path name to whichever image you want. So if you want to use this image, cat.jpg, you want to put cat.jpg. This path name corresponds to the location of your Java file. So if your Java file is here in the same folder as cat.jpg, it would use this image and not some other cat.jpg on your computer. If you have, let's say, another folder called assets and move this into here, you could grab the relative path and paste it into here, and that would also work. So you just want to give it the path name relative to your Java file. Okay, we got our first line of code down, but we're getting an error. It says unhandled exception type IO exception. This is pretty much saying that there might be errors here when we're reading the file, and we want to be able to handle that before we compile it. So what we can do here is a try and catch exception handler. Everything inside the try brackets will be run unless there is an issue. So let's say this file path was wrong. It would then skip the rest of the code down here and go down here to catch IO exception. And then we want to be able to print the error. So we do print stack trace, and that's how we print our error. Otherwise, if it was correct, it will just keep on going and we will never print an error. Now we want to resize. So we know that our width should be around 80. So this would be new width is equal to 80. Our height has to change by the same ratio that our width has changed. This is a ratio in which our new height will be changed as well. So we could just multiply that by our old height. So if we do old height, cast all of this as an int. Yeah, there's no floating point values. Or let's change old width to the actual value, which is image.getWidth. New buffered image, and this will be the resized image. I'm going to create a new buffered image. We're going to use a constructor to create pretty much a blank canvas for where our old image will be placed onto. The inputs of a width, height, and image type. This is not the image type. Our image type, so it's using the buffered image type int RGB, which basically means that it's using red, green, and blue channels, no alpha channel, and the pixels are represented as ints. So let me walk you through what I just did. So we grabbed our blank canvas. We got the graphics from that canvas, which is a way for the computer to be able to write to it. And then draw image is what's writing to our blank canvas. and we give our old image, we scale it to the new width, the new height, and we're using this scale smooth feature. That way she give our image a nice high quality look while it's being scaled down. And then we give it the position, the starting position 0, 0, and then leave this null. So this should resize our image to what we want it to be. Now we just gotta convert it all to Ascii. Let's make a function, convert image to Ascii. And let's give it our resized image. And then let's go down under the main and create our function. So we do a private static void convert image to Ascii, and we're taking in a buffered image called image. In this function, what we're going to do is we're going to loop through every single pixel in the image. First, what we need to do is we need to grab the limits, and then we're going to create a nested loop that iterates through every pixel in the image. So why did I go columns first instead of row first, which is a lot more used? First, we iterate through the columns. So we output this row, go down 1 in the column, output this row, go down 1 in the columns, output like this, and that way we're doing a nice scan of the donut. And that's what we're doing here. So we're going through the columns, and now we're going to go through the rows. Now in this nested for loop, we can actually grab each pixel. So we do that by getting int pixel and then image.get RGB. And this will take in an X value and a Y value. They are rows and columns. So we grab the pixel as red, green, and blue values, and then we want a grayscaled version. To do that, we're going to need a grayscale function. So there's two ways to do this. There's a way I told you, which is a little bit more complicated, where we manipulate the bits to get the different red, green, and blue values. Or we could just use this color class, which is a lot easier, especially for new people who are just learning how to code and learning what bits and shifting are. The easier way will be color. We create a new color using our pixel, and then we just get the red part of that color. So get red. Extremely useful and very easy to understand. But you can also do this. What does this mean? This means that we're shifting. So this means we're shifting the bits in pixel to the right. That's why they're pointing to the right 16 times. Let's say we have a 4-bit number and we want to shift it to the right 2 bits. Our 4-bit number, let's say it's 1100, then our shifted bits to the right would be 0011. And just to prevent any errors, we want to add this with FF. What is FF? What is FF? FF is an 8-bit number, which corresponds to 8 ones. We're shifting the pixel, the red values, all the way down, so they could be the first or the bottom 8 bits. We're adding those bottom 8 bits to 1, so we're telling the computer we want to keep these 8 bits, and then we're storing them in the red channel. So let's move this down only 8 bits. The blue ones are at the bottom, so we don't need to shift anything to the right. They're already at the position we want them at. And then we just end them with FF, and that's how we get the red, green, and blue values. So you could choose either or. You could choose this version or this one without using the library. They both work. Return the grayscale version, which we're going to use this formula. So it's called the luminosity method, which pretty much says that our eyes are more accustomed to green than they are to blue, and they are to red. So it's just a way of perceiving light. So we have a grayscale version of the pixel. We want to map the grayscale to an ASCII character. To do that, we want to first create our ASCII character array. So let's create that. Let's do char. It's an array, so we put the brackets. Let's call this ASCII chars. Characters, and we're gonna do our formula. So we have a grayscale image, and that's also in the range. That is in a range of 0 to 255. And then we're gonna multiply this by our ASCII characters, and then we're going to get the length. So this will give us a value or decimal value between 0 and 1, and we're going to multiply that by the length of our list, and that should give us an index depending on the value of the grayscale. So now we have our index. So now that we have our index, all we have to do is print it out to our terminal. However, there is a bit of a problem if you just do this, because doing this, it'll print everything out in one line. So what we have to do is after every row iteration, we just do system.out. So this would print a new line every row. Then also, let's cast this as a double. You would also have to cast this as a double too. I forgot to mention that. Or compile it, and then let's run it. And here is our very long cat. So this stretchiness occurs, the height of these characters are very long compared to their widths. So it will give us a very stretched image. So a way to handle that is to go back here, and we just have to make that skip every other column. Or doing this will actually make it so we skip every other row. Compile, run, and here is our image. I think it looks pretty close to the cat. And I promised you a donut, so let's go back here. Let's put this donut in assets. Rename this donut. Compile. And here we go, our donut. I hope you had fun with this, and thank you for coding with me.